Hello everyone, welcome to Dakshana e-classroom program. In this video lecture, I will be talking about the solution to last 20-year IIT questions based on chapter alternating current. So before starting that, actually alternating current, you must have gone through this chapter. It's basically quite interesting chapter, and yes, there are some conceptual things actually that like some student can find it difficult to understand or digest, but if you are understanding it properly and like connecting them, and is it able to solve and get some approach on some problem, you will find it like interesting and easy also. So main thing is like understanding the concept and solving some good problems basically. And if I look at this exam from this chapter from exam point of view, I would say it has like good weightage also. I mean like in last 20 year, not much but not less also, so quite good number of questions has been directly asked from this chapter. And this like alternating chapter, you can finish it in within 5-6 hours theoretically. You will need around 10 hour or 15 hour to digest them. I'm like practice. So if I just tell you them within 24 hours, if you're spending around 20 hours on this chapter, you will be in very good position to answer questions based coming from this chapter, right? And it has like normally we see actually in mechanics part, there are chapters which are like quite lengthy where you will be spending a lot of time, and still like there happen rarely that questions are asked directly. But this chapter has like a small chapter and directly questions are coming from this chapter, so that make it like very important. And you people must like keep this also in your important point, is it important chapters category. So let's talk about the solution or the problem that IIT has asked in last 20 years from this chapter. So we have question number 1, and it will be available to you. A 10 centimeter long perfectly conducting wire PQ is moving with velocity 1 centimeter per second on pair of horizontal rails as shown in figure, horizontal rails of zero resistance. Okay, on one side of the rail is connected to an inductor 1 millihenry and resistor R 1 ohm as shown in the diagram. The horizontal rails, okay, L and R lies in the same plane with a uniform magnetic field B equal to 1 Tesla perpendicular to the plane. If the key S is closed at if the key S is closed at certain instant, the current in the circuit after 1 millisecond is x into 10 raised to power minus 3 ampere, where the value of x, so that is the problem. Assume the velocity of wire PQ remains constant, that is 1 centimeter per second, after which key is closed, and given e raised to power minus 1 is 0.37, where e is base of the natural logarithm. So this is the problem. Let me draw the diagram. It should be available to you, visible to you. So the diagram it's saying is that here we have one inductor and one resistor, and this is basically switch. These are horizontal rails and one wire, conducting wire PQ, it's moving with constant velocity v, and there is a uniform magnetic field directed into the plane of paper lying everywhere, is it like this, and its velocity is 1 centimeter per second. And PQ, length of the wire L is 10 centimeter also, and B is given as 1 Tesla. L of this inductor L and R, L is given as 1 millihenry and resistance is given as 1 ohm. So this is the information provided to us. And let's suppose this switch is closed at t is equal to 0, and this rod PQ is moving constantly with the velocity 1 centimeter per second. Then after t equal to 1 millisecond, we are asked to find the current in the circuit current, basically I, that comes out to be x into 10 raised to the power minus 3 ampere, and it's also mentioned to you that value of e power minus 1 is 0.37. Okay, so this is the problem and let's solve it. I think like if you are just looking at the problem and thinking about it, then it should be even like striking in your mind that how we will be approaching it, because it's the problem is not really very difficult, it's quite easy. And let me show you the solution, you will find it definitely easy. Okay, so what is happening, like at t is equal to 0 we close the switch, then this is L R, and what is happening, what is the role this PQ wire is playing here? It's moving in constant magnetic field or uniform magnetic field perpendicular to the plane of the wire, is it, or plane of this circuit diagram, with constant velocity. So the EMF developed in the wire, EMF in wire will be equal to what? E equal to VBL. Clear? And V is given as 1 centimeter minus 2 into B is 1 and L is also 10 centimeter, that is 10 by 10. Clear? 10 centimeter by 100, so effectively 1 by 10 this. So this comes out to be basically 10 to the power minus 3 volt, so 1 millivolt. So this is the EMF developed in the wire. And because see, velocity is maintained constant, B is definitely uniform, L length is not changing, so I can write every time this is constant. What it means simply if I just look at this circuit, it will be equivalent circuit. The equivalent circuit will be like this. This is L, this is R, and this is a battery connected. See, right? And it's like switch is closed at t equal to 0. So what it is, this is simple LR circuit, is it, with battery, and polarity we can decide here, V cross B, so it will be like force on positive charge will be upward and negative charge will be downward. That way we can write the polarity. Clear? Okay, so this is a simple LR circuit. Clear? And then I can write basically this implies current I can be written as in LR E by R 1 minus e raised to power t over tau, and tau is equal to what? Tau is L by R, right? So and here time is given 1 millisecond. Let's substitute here everything. So we are getting first let me get tau is equal to L, that is 10 raised to power minus 3, 1 divided by 1, so it's 10 raised to power minus 3 is tau, and let me substitute now. So I is equal to E, 10 raised to power minus 3, R is 1, and this is 1 minus e raised to power minus t. T is how much? 10 raised to power minus 3, and tau is also 10 raised to power minus 3. What it comes? This is simply minus 1. So this is 10 raised to power minus 3 into 1 minus e raised to power minus 1. And what is the value of e raised to power minus 1? It's given as 0.37. So this is 1 minus 0.37, that will be 0.63, and this is minus 3, so I is coming out to 0.63 milliampere, or you can write 0.63 into 10 raised to power minus 3 ampere. So the answer, the value of x by comparing these two is coming out to 0.63, and this is the answer to the problem, right? So I hope it should be clear, and you can see like there is nothing actually much complex in this problem. Most of the time the things are like not very complex, but yes, it's really true that the topic is quite conceptual and it has like lot to understand, right? So first make sure you are going through every topic properly and you are getting it conceptually clear, right? Then you will be in position to answer the questions based on coming from this chapter quite easily. So let's see the next question. Okay, see the next question. In the circuit shown, L 1 microhenry, C 1 microfarad, and R, that is 1 kilo ohm resistance, they are connected in series with an AC source. Voltage V is equal to V naught sine of omega t as shown. Which of the following option is are correct? A. The frequency at which current will be in phase with the voltage is independent of R. B. Omega almost tending to 0. The current flowing through the circuit will become nearly 0. And C. At omega very greater than 10 to the power 6 radian per second, the circuit will behave like a capacitor. And the D. The current will be in phase with the voltage if omega is equal to 10 to the power 4 radian per second. So let's see the actually answer. So this is question number 2, and the circuit given, first let me draw it. It's inductor, capacitor and resistance with LCR series circuit and connected to a AC source. Okay, so AC source is given as V naught sine of omega t. LCR, L is given as 1 microhenry. C is also given as 1 microfarad capacitor, and R is 1 kilo ohm. Okay, this is the information given, and now we need to check for the options. Okay, all right, so see, it's saying first option, what at the frequency at which current will be in phase with the voltage is independent of R. First you need to understand like what will be that frequency for which the current is it in the circuit will be in phase with the voltage, and you must be understanding that it happened at the frequency of resonance. Clear? Normally in general terms we can write actually Z is equal to what? Under root XL square, XL minus XC whole square plus R square. XL omega L, XC 1 by omega C, and R is R, and current in the circuit is given by V naught by, this is peak value, you can write Z, and we want like for current to be in phase with it. A option, for current to be in phase, that means Z should be equal to R, right? And this will be possible when X, that is equal to XL minus XC, this is equal to 0, and this implies XL equal to XC, and this is omega L is equal to 1 by omega C, this implies omega equal to 1 by under root LC. You can check it, this omega, we call it resonance frequency, it's independent of R, so that's true that at this omega, where at which the current will be in phase with the voltage in the circuit, is it? The frequency is independent of R, so that A option is true, and we can get the R, that is coming out to 1 by under root 10 to the power minus 6 into 10 to the power minus 6, that comes out to be 10 to the power 6 radian per second. So this is the resonance frequency. Okay, let's see the next option, B. So it's saying next option, just 1 second. Alright, so in saying at omega tending to 0, the circuit current flowing through the circuit will be becoming nearly 0. So see what is happening, omega tending to 0. What will happen? Actually in that situation, when frequency is 0, right, the circuit will behave like a DC source, is it? Or you can write, if omega is equal to 0, in that condition, okay, so in this situation omega tending to 0, it's like a DC source connected, right? And जब DC source connect किया जाता है तो उस situation में you must be familiar, you must be clear that at after long time capacitor get fully charged and then no current is allowed through the circuit, is it? So after capacitor is fully charged, no current will flow, right? So that means it's a right statement. Clear? So A and B both are correct. C, omega very greater than 10 to the power 6 radian per second. What means? It means omega very greater than omega resonance. Now you can check it. If this is the condition, we can see it here, XL and XC. If omega is increased, this will increase, this will decrease. तो यहाँ पे जो हमारा reactance है, reactance will be what? Capacitive or inductive? Reactance will become, it will be inductive. रिएक्टेंस कैसा हो जाएगा? इंडक्टिव. तो सर्किट कैसा बिहेव करेगा? इंडक्टिव, नॉट कैपेसिटिव. सो इट्स मेंशनिंग द सर्किट विल बिहेव लाइक ए कैपेसिटर? नो, इट विल बी बिहेविंग लाइक ए इंडक्टर. सो सी इज नॉट राइट. एंड डी, the current will be in phase with the voltage if omega is equal to 10 to the power 4 radian. So omega equal to 10 to the power 4 radian per second. We know only current is in phase with the voltage when omega is equal to omega resonance, and omega resonance is 10 to the power 6 radian per second. So definitely at this there will be like no possibility of having current in phase with the voltage, right? So you can see also this is not very like difficult. It's simple straightforward problem if you are familiar, if you are clear with the concepts. Okay, next question number 3, and just I want to tell one more thing actually. ये कुछ क्वेश्चन इसमें ऐसे लग रहा है they are from EMI actually. So yes, actually they are from EMI. Mistakenly they has been placed in AC. So but our objective is to understand the concept, understand the problem that IIT has asked. So I'm sorry for that like it has been like misplaced, sort of like EMI questions we are discussing in AC, but still these two chapters are a little bit or quite connected, so you should not have any problem. And make sure that like your focus is more on understanding and getting your doubts and cleared, and is it getting the concept and confidence, not on like connecting it to which chapter it exactly belong. Yeah, so I already informed, I like told you about that. Okay, so let's see one more problem actually here. So in the figure below, the switch S1 and S2 are closed simultaneously at t equal to 0 and current start to flow in the circuit. Both the batteries have the same magnitude of EMF and the polarities are as indicated in the figure. Ignore mutual inductance between the inductors. The current I in the middle wire reaches its maximum magnitude at t equal to some tau. Which of the following statement is are true? So A, I max is equal to V by 2R, B, I max is equal to V by 4R, and C, tau L by R ln 2, and D, tau equal to 2L by R ln 2. So these are the options. Let me first draw the diagram. So here diagram given is, this is R inductor, and then one more R inductor, and it's connected to a battery with this polarity, remember, and here connected to a battery with this polarity, right? And this is the system. So this is given as switch 1 and switch 2, and both are connected in this manner. So here you are asked to find the current I, and it will be maximum at some time, and this is EMF V, this is also EMF V, this is R, this is L, this is R, and this is 2. Clear? Which of the following statement is our option is our correct? So now let's see it. Let's look at the like problem. So what is happening? Both switches are closed at t equal to 0, closed at t equal to 0. Now look at it. What is current will be, how it will be flowing through the circuit. So if I just look for the circuit at t equal to 0, actually at t equal to 0, current through the inductor will be equal to what? 0. It doesn't allow the current to increase immediately, right? So that's why current in this circuit will be 0. And exactly in the same manner, I can write current in this circuit will be also 0. So at t equal to 0, current will be 0, right? Okay. And what is happening at, let's say, t equal to infinite time? It means after long time. What will happen at that time? We must be aware that after long time, what exactly or how exactly inductor behave. इंडक्टर क्या है, ऐसे काम करता है लॉन्ग टाइम बाद कि जैसे वायर की तरह, मतलब कुछ है ही नहीं. तो उस सिचुएशन में क्या होगा, यहाँ से करंट देखो कैसे जाएगा, वो इस तरह से जाएगा एंड इट विल बी इक्वल टू व्हाट, I1 इक्वल टू E/R. इसमें KVL लगाता हूँ तो, और इसमें KVL लगाऊंगा तो यहाँ पे भी ये L का कोई काम नहीं है, सो सॉरी V/R, and I2 you can write is equal to V/R. Means this is what maximum current, right? And this is maximum current. तो इस वायर से देखा जाए तो शुरू में भी 0 है, लास्ट में भी 0 है, and what will happen, the current will be KVL applying in this loop and KVL you can apply in this loop. There is no resistance, it's not going to play much role, is it? So one current I1 will be flowing this way and I2 will be flowing this way, and the net current I can write I will be equal to what, I1 minus I2. Clear? So let's get the I1. So now what is there, is it for, actually you can even I'm just trying to explain you, that's why it's taking a little bit of time, and I'm trying to keep your focus on every point, otherwise it's just a question can be solved in fraction of seconds or only in few seconds. Okay, so for calculating I1 basically, तो ये जो सर्किट है तुम्हारा वो इफेक्टिवली कैसे होगा, ये ऐसे इंडक्टर, रजिस्टर and this only battery is connected. This circuit is equivalent to like this is L, R, V. तो यहाँ से मैं लिख सकता हूँ किसी भी टाइम पे I1 is equal to V/R 1 minus e raised to power t by tau, and tau is equal to L/R. So this is I1. Similarly for calculating I2, the equivalent circuit will become simply this is R, L, and this battery connected in this manner, L, 2L, R, and this is V. Now here current will be flowing in this manner, और यहाँ पर भी अपन ने क्या देखा, देखो मैक्सिमम पीक करंट अपन ने निकाल लिया, और LR सर्किट में टाइम t पे करंट क्या होगा वो अपन को एक्सप्रेशन मालूम है, तो उसी को हम यूज करके वी कैन राइट V/R 1 minus e raised to power t by tau, tau is 2L/R. So this is the current in that circuit at time t. So net current, is it, across this part, so net current I through middle wire, that can be written as what, I equal to I1 minus I2, substituting it I equal to V/R 1 minus e raised to power RT by L minus 1 minus e raised to power RT by 2L. Clear? So this is the next part, and simplifying it, यहाँ से अपने पास क्या आ जाएगा, देखो 1 gets cancelled, this is plus, this is minus, so it's I is equal to V/R e raised to power minus RT by 2L minus e raised to power RT by L. This is the current function of time. Now it's saying we need to minimize it, is it, or maxima, it's talking about the maximum current. For I max we can write di by dt should be equal to 0, एंड डी आई बाई डी टी कितना हो गया, दिस इज वी बाई आर, डिफरेंशिएशन ऑफ दिस माइनस आर बाई 2l e raised to minus rt by 2l plus r by l e raised to minus rt by l equal to 0. इसको सिंप्लीफाई कर देते हैं. Okay, so let me erase this part. So simplifying that, this you can take v by r and I am taking r by l also out, so it's minus e rt by 2l divided by 2 plus e minus rt by l equal to 0, and this implies this is equal to that, and bringing it this side, and it's e power minus rt by 2l divided by e power minus rt by l equal to 2. This you can write e power rt by l minus rt by 2l equal to 2. ये सब्ट्रैक्ट करके e पावर माइनस प्लस rt by 2l equal to 2, taking ln both sides, so this implies rt by 2l is equal to ln 2, and that implies t equal to 2l by r ln 2. So we got this is the time at which current will be maximum in the circuit. Clear? So the time at which current will be maximum in the circuit is this, and Imax can be written, calculated. Imax will be equal to what? V by R e raised to power this. Let's substitute, I mean not this, here. So if I am substituting here this, then what will happen actually, right? So it will be t is equal to this, right? Then what it basically equal to, so 2l by r, it's getting cancelled, and it's e power, basically this is minus ln 2, minus can be taken inside, so it's basically 1 by 2, and minus here e power, this is minus 2 ln 2, so this is 1 by 4, so we are getting v by r 1 by 2 minus 1 by 4, and that is equal to, taking LCM, v by 4r, so this is the I max. I hope like it should be clear. अपन ने क्या किया सर्किट में, दोनों I1 I2 निकाल लिए बिकॉज इक्विवेलेंट सर्किट, कैलकुलेटेड नेट करंट, और ये अपने पास फाइनल एक्सप्रेशन आ गया. अब इसको मैक्सिमाइज मिनिमाइज करना है, जस्ट मैथमेटिक्स, राइट? तो डिफरेंशिएट करके टाइम अपन ने निकाल लिया, एट व्हाट टाइम करंट विल बी मैक्सिमम, इज इट विल बी मैक्सिमम एट दिस मच टाइम. इस टाइम को यहाँ पे सब्सटीट्यूट कर देते हैं, तो अपन ने मैक्सिमम करंट की वैल्यू भी निकाल ली. दिस इज प्रॉब्लम, राइट? Okay, so the next question is, two inductor L1 inductance 1 millihenry, internal resistance 3 ohm, and L2 inductance 2 millihenry, internal resistance 4 ohm, and a resistor R of resistance 12 ohm, all are connected in parallel across a 5 volt battery. The circuit is switched on at t is equal to 0. The ratio of maximum to minimum current drawn from the battery is, so this is the problem, and the diagram is will be visible to you on board, and I have drawn it here also. So this is our circuit in a given 1 millihenry and inductor resistance 3 ohm, 2 millihenry inductor. So let's say this is L1 and this is L2, this is R1, this is R2, and R3, that is 4 R3, 12 ohm. All three are connected across a battery 5 volt in parallel, right? This is the circuit given to us. Now what it's asking, the maximum current will be withdrawn from the battery and minimum current at some moment. The ratio of this is asked to find, right? So the simple question is that here we need to understand that at what moment the current withdrawn from the battery will be maximum, and what will be the condition, what will be the criteria for that, is it? And like, to think about that, you must already understand that why, like, at that moment, how that happened actually, right? So we know actually that if a inductor is connected across a DC power source, then how it behave at t is equal to 0, right? It is clearly mentioned in the problem that switch is closed at t equal to 0, right? So at t equal to 0, how inductor behave? So you know actually at t is equal to 0, this inductor is equivalent to what? Simply open circuit. And this is at t is equal to 0. T equal to infinity means long time after, inductor is equivalent to what? A wire. Right? So this is the basically information or knowledge concept we require to solve this problem. And now let's see how we can solve it. Where is it? So t equal to 0, inductor will be like open circuit, means current withdrawn from across this will be like open circuit, so means 0, 0. So whatever the current will be withdrawn only across this. So it is the, like you can see, it will be the least current, right? Or minimum current. So minimum current will be withdrawn at t equal to 0. Clear? And that will be like, so we can write the equivalent circuit at t equal to 0. So that is equal to what? This is open circuit and resistance. This is also open circuit and resistance. And another, this is 12 ohm resistance, and this is connected. This is 12 ohm, 4 ohm and 3 ohm. So effectively, like, whatever the current I withdrawn from the battery, I minimum, will be equal to what? I1. Clear? And this implies I minimum will be equal to 5 divided by 12 ampere. So this is the minimum current. I hope it should be clear, because concept is simple and then solving it. And we can understand maximum current will be withdrawn at t equal to infinity, right? And the equivalent circuit at t equal to infinity, inductor is behaving like a simple wire. So at t equal to infinity, I can write the equivalent circuit will be this inductor, resistance, inductor will be like equivalent wire, resistance, one more resistance, and this battery connected. So 5 volt, 12 ohm, 4 ohm, 3 ohm. So R equivalent, all three in parallel. So then what is R equivalent? So 1 by R equivalent is equal to 1 by 3 plus 1 by 4 plus 1 by 12. This is taking LCM 12, and this is 7, and one more 8 LCM total. So this is coming out to 8 by 12, and R equivalent is equal to what? 3 by 2 ohm. And I max is equal to 5 by 3 by 2, that is 10 by 3 ampere. Now it is asking the ratio of I max by I minimum, that is equal to how much? I max 10 by 3, 10 by 3 divided by how much? This is I minimum is 5 by 12, simplifying it, 10 by 3 multiplied by 12 by 5, this is 2, this is how much? 4, so it's coming out to be 8, and this is the answer, I max by I minimum. So the answer to the problem is coming out to be 4. So the ratio of maximum to minimum current is 4. Just check the calculation, approach should be clear. how we can think about it logically, that should be even clear, because if you are aware of this information, if you are knowing this concept, this logic, then it's simply straightforward problem. If you are not understanding, not knowing this, and this is a basic concept basically that we study in case of inductor, that how it behave in case of DC circuit, right? So okay, so the next question will be visible to you here. Let me read it. In an LR series circuit, a sinusoidal voltage V equal to V naught sin omega t is applied. It is given that L equal to 35 millihenry, R equal to 11 ohm, V RMS 220 voltage, and omega by 2 pi is 50 hertz, and pi 22 by 7. Find the amplitude of current in the steady state and obtain the phase difference between current and voltage, and also plot the variation of current for one cycle on the given graph. And here we are given a graph of voltage versus time. So this is the problem, and so the question here given is that we are provided, this is V versus T graph, right? V versus T graph for a sinusoidal, and it's LR series circuit with L equal to how much? 35 millihenry, R equal to 11 ohm, V voltage applied is given as V naught sine of omega t, and V RMS is given as 220 voltage, and what else, like omega by 2 pi, that is given as 50 hertz. So this is the information given to us, and we are asked to find the amplitude of current. So current amplitude, right? This is one, and phase difference between, so phi between voltage and current, and plot. These are three main part has been asked in the question. So let's see it one by one. Okay, so here we are given actually series LR circuit. So LR circuit will be like this. Series LR, this is the equivalent circuit, and it's connected to an AC voltage, that is V naught sine of omega t. This is the voltage, this is L and R. So alright, and VRMS is given, so what we can write from here, I can write V naught is equal to VRMS root 2, so that is 220 root 2 voltage will be the V naught peak voltage, and that's all. Okay, so what is Z in this case? Z is equal to under root R square plus XL square. Clear? And XL is equal to omega into L. We have provided everything, right? So this is coming out to be omega, we can substitute 50 into 2 into pi 220 by 7 multiplied by, this is L, 35 into 10 to the power minus 3, and R we are given already, it's 11 ohm. Let's simplify it. So this is coming out to 50 into 2, it's a 22, so and 7, 5, is it 15, 2, and this is also coming out to be actually 11 ohm. So XL is equal to 11 ohm. Clear? Then Z impedance is equal to under root 11 square plus 11 square, that is equal to 11 root 2. This is the impedance of the circuit. Okay, so we got it up to here, impedance of the circuit. Now it's asking current amplitude. So current amplitude, we got the voltage amplitude, this voltage amplitude, that is 220 root 2 voltage, impedance 11 root 2, and current amplitude, that is V naught by Z. So this is coming out to be 220 root 2 divided by 11 root 2, and this is coming out to 20 ampere. So we got the answer to part 1, that is current amplitude. We are getting it 20 ampere, right? Okay, next it is asking the phase difference. So phase difference between voltage and current, that we can write 10 phi is equal to what? So in this situation, if we draw its phasor diagram, actually it comes here. What is there? Voltage is same. This is V, is it? Or VR, and that will be also same. And IR will be here, and IL across inductor will be like current will be lagging behind the voltage by 90 degrees. So net I will be somewhere. This is I net, and this will be the phi. So phi I can calculate. This is comes out to be XL by R, and this is 11 by 11 equal to 1. This implies phi equal to pi by 4. Right? So the phase difference between voltage and current, we are getting pi by 4. One more thing is, here we can see, in case of inductive circuit, voltage leads the current. That means current will be lagging behind the voltage, right? So here we can write current will lag the voltage by pi by 4 phase angle. So then I can write what will be my current. So I equal to I naught sine of omega t minus pi by 4. Clear? And I naught I already got 20 sine of omega t minus pi by 4. So this will be the actually current equation. Now if we want to plot the, so if this is the voltage plot, then we just need to shift the current plot by like pi by 4 backward, is it? So it will be shifted by pi by 4 backward, something like this. Like here the amplitude will be also different, so we just need to take care of that too. So it will, the current I will be equal to, this is I equal to 20 sine of omega t minus pi by 4. Clear? And so here the amplitude will be what? 20 ampere. And at 0, we can substitute here omega t equal to 0. So it will be I naught sine of pi by 4. That comes out to be basically at 0, the current will be, it's minus 10 root 2 ampere. So this is the problem. Again, the thing is that here you must be clear with the concept, logic, what exactly happened. Here important thing is, okay, this is simple part, getting impedance, and that is also straightforward things. Phasor diagram is quite important. Otherwise, what is that? Like we calculated JEE, impedance, current amplitude, simply voltage amplitude divided by JEE. Calculating phase difference, phase difference is also equal to, because we know it's already XL by XR. Getting it whether it's leading or lagging, for that you need to remember this phasor diagram in your mind. So that you should keep in your mind, phasor diagram. Then you will get this, and once you have this and you have amplitude, then you can automatically write यहाँ जो तुम्हारा voltage है उससे क्या करना है, करंट को lag कराना है. Sub means lagging means subtract, negative, so by phase angle pi by 4. And if this is your voltage curve, that is 220 root 2. Remember peak voltage is 220 root 2. So it will be 220 root 2 sine of omega t. तो अगर ये तुम्हें voltage दे रखा है तो करंट को क्या करना है, इससे लैग कराना है by phase angle pi by 4. और That's on here, right? Is it situation? So simplifying it, we are getting, and this is the equation, this is your phase angle, this is your current amplitude, and this will be the plot, and this is all about the problem. Hope it makes sense to everyone. Okay, so see the next question here. It will be visible to you. A series RC combination is connected to an AC voltage of angular frequency 500 radian per second. If the impedance of RC circuit is given as R under root 1.25, the time constant in millisecond of the circuit. So this is the problem. A series RC combination. So here it's given series RC combination connected to an AC source. This voltage of angular frequency, so omega is given as 500 radian per second, and if impedance of the circuit, so Z is given as R under root 1.25, then time constant tau is asked to you in millisecond. This is the problem, right? And let's calculate it. So omega we are given, let's say the resistance is R and capacitance is C, then what I can write, R is R and XC is equal to what? 1 by omega C. So Z will be equal to what? Under root R square plus XC whole square, and this is given as how much? R under root 1.25. Let's square on both sides. On both side. यहाँ से क्या मिलेगा अपन को? Squaring it this and that, so it's basically R square plus XC square equal to R square into 1.25. Taking it that side, we are getting XC square is equal to 0.25 into R square, that is R square by 4. So XC is equal to how much? R by 2. We got it up to here. Clear? Okay. And XC is what? 1 by omega C equal to R by 2. This implies RC is equal to what? RC is equal to 2 by omega. And what is tau? Tau is equal to RC. So means this is equal to what? Tau, and tau is equal to RC equal to 2. Omega is 500 radian per second, and simplifying it, it comes out to be tau equal to 4 into 10 to the power minus 3 second, and so it's 4 millisecond. So tau in millisecond, it's basically 4 millisecond, and this is the problem. So finally we are getting the value of tau is 4 in millisecond, and this is your problem. So it's simple, straightforward problem.